Okay, folks, these are the video directions for Angular Momentum and Collisions Lab. So you need to join our Pivot Interactive class, and then this is the only thing that's assigned. So you should click on that. And there's only one part. I wrote these directions. You can change these videos to be colliding with a soda can, which we don't want, or we want the wood block, and we want location 6 because that is, apparently a good distance from the pivot. So you need to make sure you hit this load button. So wood block 6, load. That you have chosen the correct video. Then the next thing, it's really important that you do is click on full screen. All right, and then this is what it will look like when you open it up. And up in the upper right corner is a tool icon. We want initially a horizontal ruler tool and a stopwatch tool. Pick up the stopwatch and get it out of your way. Okay, and then you're going to go down and go frame by frame, and then what you want to do is anywhere from frame 8 to frame 29, you are going to, in the data table number 1, you are going to record the location of the particle. So this is like 4.8, 4.9 centimeters. It's fine to leave it in centimeters. So you would write down 4.9 centimeters at 0.007143 seconds. And then you'll move forward. Oh, that's perfect. That's 17 at 0.01714 seconds. You want to don't do every single click because you're only going to take 5 data points, and you want them to be spread out because the bigger the time interval, the bigger the total time interval over which you take data, the smaller a 1/10 of a second error will be. Okay, so write down 5 locations and their matching time for before the particle collides. One person can do that. And then the second person will wait until after the collision, and now you can see it's traveling more slowly, right? Because every time I move forward a frame, it doesn't cover as much ground on the ruler. Person number 2 will also write down, 47 centimeters and the timestamp that goes with that. So person number 2 will fill out the data table number 2 for the object going left. Okay, so using those 2 data tables, we're going to use Desmos to calculate the incoming velocity, which is going to be positive, and the outgoing velocity, which is going to be negative, so that we can calculate the initial and final linear momentum. Okay. Then person number 1 or person number 2 goes back in time, and now we're going to focus on the 2x4. So its momentum before the collision is 0. It's got no linear momentum. It's got no angular momentum. You might want to move the ruler to now cover this portion of your screen. You're going to be focusing on the center of mass of that wood block. And make sure you do it after the collision. So I would err on the side of there might be some friction, some external forces with this little platform. So I'd make sure it's not touching the platform anymore. And then go ahead and move the ruler to a nice clean value. So 40 or whatever you want. Write down the location and the time. And then again, you're focusing on the center of mass. So there's that little black dot in the middle of the white piece of tape. write down the location of that and the time. And again, try to, it is, you can see kind of falling a little bit due to gravity, but horizontally that shouldn't change its velocity. So you're going to choose 5 easy to read positions and the matching time. Don't move, once you've moved the ruler, don't move it again, right? So have the ruler over here for the particle, have the ruler over here for the rotating board. So you have just tracked the linear velocity of the board. And now we are done with this horizontal ruler. So I'm going to slide the view frame up. We can get rid of that. We don't need it anymore. And we're going to do one more set of measurements that is a little bit tricky. So we want the, I don't know what they call it, protractor. And we're going to do, we're going to go back here. And you're going to put the protractor at the center of mass. And you are going to read the angle. And you can see they are using the unit circle, so the angles go counterclockwise. So don't copy my data, but what I have is at this time, it's almost, what is it, 60, 70, 80, so almost 70 degrees dead on. And then err on the side of getting a lot of angles, because this is going to, I think, the least accurate. So then have it go through have it do many clicks, because then it will have moved through a large amount of angles. You're going to have to move your protractor over so that it's again at the midpoint to read that angle. And then do some more clicking and read what that angle is. Again, you're looking at like the continuation of the midpoint of that 2x4, right? So this would be like halfway between 10, like this is 10, so like 15 degrees. All right, so you're going to record. I had you do 1, 2, 3, 4, 5, 6, 7 of these just because I feel less confident that these are going to be good. Maybe you want to try to catch 0 dead on. And don't know what's going to happen that these angles are going negative. So I'll take some data and see. Instead of calling this 330, I think you should call this -10, -20, -30. But I will take some data and see. Once you have the third data table filled out, you are done with what you need to be in this application for. And then you're going to, I think you know how to curve fit in Desmo, so I'm not going to make a video directions for that. All right, hope this makes sense. And we are done.